Hello everyone, my name is Zara and I'm a PhD student at Colorado State University. The topic of my thesis is Annotation in Asynchronous Collaborative Immersive Analytic Environment using Augmented Reality. Augmented reality is a technology that merges virtual objects with real world. Immersive analytics, which is a new term referring to the use of immersive technologies such as augmented reality or virtual reality for data analysis. Finally, we have asynchronous collaboration, which means multiple users can work on the same task at different times. Before emerging immersive technologies, the only option for data visualization were paper and pen and 2D displays with their associated inputs, such as pen or keyboard, mouse, or display touch. Nowadays, immersive analytics and augmented reality head-mounted displays such as HoloLens provide a new paradigm for the user to explore multidimensional data in an immersive environment. Here is a short demo of my environment. As you can see, user can explore and interact with the data using freehand gestures. Users can filter or show all of the annotations to avoid cluttering.
As you can see, there are different type of annotation. Let's play the audio one.
If you look at the first plot, you can see the quality is
Now play the video.
Our area of interest is in the intersection of these three domains: annotation, which can be in 2D or 3D, immersive analytics, and collaborative augmented reality or virtual reality. Li et al. Explored immersive analytics in a symmetrical, synchronized, collaborative environment. They use virtual reality and also they use annotation in their system, but their main focus was not annotation. Fonet et al. Surveyed 177 papers in the context of immersive analytics. They found only 8 papers used annotation and highlighting in their system. When it comes to data visualization and annotation, papers in 2D are a valuable resource. Here, Kim et al. Investigated how users externalize their thoughts during data analysis. They found users prefer to generate graphical annotation, not textual annotation. They also found what were annotation about, for example, about correlation, plots names, and so on. In another study, Ren et al. Introduced Chart Ascent, which is a web-based annotation application for data analysis. They explored data-driven, they actually explored data-driven storytelling technique. And finally, we have Garcia 20, which uses handheld augmented reality for inspecting a building. Users can generate annotations for an asynchronous collaboration. They can create image notes, hand drawing, and 3D models, and then later another user can review these generated annotations at different times. To have a better understanding of annotation in AR/VR, we surveyed a total of 85 papers from ACM Digital Library, Alter Video Explorer, and Spring Learning. Here you can see 29 papers out of 85 papers were collaborative, and the bar plot shows our surveyed papers, the distribution of the surveyed papers based on their collaboration type. As you can see, most of the system use remote synchronized asymmetrical collaboration, and very limited number of studies investigated asynchronous collaboration. To the best of our knowledge, almost all of the previous studies on immersive analytics focus on synchronized collaboration. However, if we believe that in future people are going to use immersive analytics in their daily life, asynchronous collaboration is an inseparable part of it. Here we define and classify the annotations based on the previous studies. We classified the annotation based on their form, their creation method, target are allocated, and also their dimension. The bar plot shows the distribution of papers based on their annotation form. As you can see, users and most of the system use text, textual annotation, 3D models, hand drawing, highlighting, images, audio, video. And here shows what we use in our system. We use text, 2D models, downlines, images, audio, video, annotation. My research includes a series of studies aimed at exploring different annotation forms and techniques for analyzing 3D data visualizations, such as the scatter plots, and we use Microsoft HoloLens 2 for this experiment. So in the first study, we want to compare different forms of annotation to find out which form of annotation are favored more by the viewer. In the second study, we want to evaluate user behavior and their priorities in a cluttered scene using filtering technique. So user can filter some of the annotations based on annotation forms, confidence degree of the annotator, or plot number. Here we want to, for example, filter some of the annotation based on the annotator. And then in the third study, we want to evaluate a data-driven technique in annotator mode, meaning user need to allocate each generated data annotations to a specific target, such as data items, access, prior annotations, and etc. In the fourth study, we want to investigate the effect of storytelling annotation on user understanding. So users generate annotation like previous study. However, they need to assign a number or an order to each generated annotation, so that in the viewer mode, this generated annotation will be shown in a specific order to tell a story. Okay, here are some of the questions that I would like to get feedback on. Is there any other annotation technique in 2D that I should consider? Should I compare the experiment with the 2D based version? Has an important metric been overlooked? Do you have any recommendation to improve this work? And what other research question can be answered by similar experiment using this system? Thank you very much for listening.